The broadcast is now starting. All attendees are in listen-only mode.
You're right.
I leave the AWS after and the fact that next door. Yeah. Cheers. Yeah.
Can we set the front ones and guys? Oh, do you mind?
No, you don't mind. Yeah.
We'd have to do food.
Is there anything?
Yeah.
Yeah, that's
Oh.
good.
Yeah.
You guys want hand sanitizer?
Yes, please.
Okay. Oh, sorry.
Actually, do not do because I got my hand. Oh, child. Cucumber.
Go on. Celebration.
Do you have these little cucumber? Right.
This jumper is going to have to
Nice. Yeah.
Sorry.
Shall I watch my stuff?
That's leave it. It's just right up there, isn't it? Good luck to you. Oh, they're trying to books. These might be there to look up.
Yeah.
Yeah.
Scott reports over there, so presumably there's more than just one of those little capitals.
There's one. Oh no, that's like. I think those circle things come off the floor. Oh no, there's too many of them. You got my factory?
Yeah, yeah.
There you go.
Well, there's 3 ones.
There's a free one.
Okay. No, I've got like 60%, but probably the maximum is a shit.
But at least they charge quickly.
Mm. Wish that was fine.
Number one is just network marketing.
Yeah. What about? I have to do it for 4 hours ago. Oh, the hair lighter.
Maybe you'll skin as well.
Yeah, I would recommend that you can do it.
It's really nice. Fish my shoes. Husband?
Huh?
Not as many people today, so it's 26. And it's not that many people. Also. Oh no, I think it's also a half 6. I think we get her. Hi.
Bridge!
Bridge.
I had to report a breach today.
What?
Some guy just like his
Something said the
key.
use your weapon, so
Amazing.
yes, we're going to have to assume it on the end of the. Okay, I guess I bounce it. Right, that's all. Yeah. What we normally do is basically by the cycle, surprise the conference.
Is it a bridge?
Okay.
It is a bridge, but like you're going to do it.
Alright, so it's like,
Because that's not going to happen.
That's
We're
gonna
going to do the
No.
workshop.
So I didn't know you were
Because I thought it's a workshop that you're going to.
I only got 2 hours then told me to.
Yeah, that's right. So what you do is you join the conference. Okay.
FYI, just send subject anything before that comes after.
What? What's the direction?
Like them closing
Oh
down.
my god, that's so dramatic. Actually.
What are they looking at?
One of this construction on Azure, it's like a sandbox and there's nothing in it. And it says there's nothing in it.
The last message from him is, I'm kind of just fed up right now, to be honest. He knows he's drunk.
He really did want to take the TL position. He got like, really convinced into it because he knows he said he'd rather be more technical than managerial. And like in hindsight, maybe not that he's bad, but like maybe he would have enjoyed a less managerial job.
I don't know what the job is like.
Yeah.
He just directly manages whatnot, so I don't know what he
So other managers do, because I have never worked in any other.
Well, yeah, like, obviously, but it's different because of the way you're like being sent stuff through. Like, do you accept tasks with manager or something? Like, really, it's every day. But it's just, you shouldn't work in anything like this, you could be making like deliverables.
Yeah, I like being quite independent like this, but then, yeah, I don't know what he does. I guess when we join a service team, they'll be directly like, actually, no, I think that's the whole point of our job. That we get stuff from this front and we get on with it.
Yeah.
That's the whole point, isn't it? Yeah, yeah, cool.
I don't want to get this virtual restaurant.
Yeah, cool. How's that?
Like how bad is it bad very good? Maybe it's not.
Yeah,
Does it happen? Okay. Well,
that's nothing I usually do.
I watched an article.
Mhm.
No, I watched a documentary. Native combustible in art combustible in the soil. You have to heat up to a certain temperature and then they're combustible.
Oh,
So you have to put
I mean, it's better than plastic, but yeah, I guess.
that's not very, it's not what it's used.
Which is when we need to get our toss on box. So you don't have them. Probably the one food that might need vegetarian.
Even like meat and fish, did you eat a shrimp? Did you know that? I do what it's like.
No, I don't. I mean, people tell me that it's like contributes whatever tastes the same, I can guess. But I have no idea. No.
It's quite good.
Have you been vegetarian for a while? And vegan not at all?
Like, started transitioning about 2 years ago. 2017. Well, it wasn't so easy at home, so
Yeah.
now,
That one?
very free.
What do you mean?
Food for himself.
I put myself, so I have a bit more autonomy.
How do you do that?
What, since I got back from uni?
22 years.
Yes, since you go back to me.
A year, yeah, a yearish. But then during that time, they were away for part of the time, or I was away, so I was.
I do really food so much. Like my mum is like, she does like too much basically. Like, like meals and
Really?
but it's like as I get home, like she'll like. Yeah,
My dad would not do it any way. Like, he,
and it's nice. That's why I'm really gonna miss it. Like it literally on the table as I got home.
okay.
That's not nice. No, but
That's
I'm gonna
nice.
miss that. You know what I mean? It's like.
You're going to move out when you go back?
I was like forecasting that it would take us 2 years. But it might take a bit longer. It depends like on this job.
Is it living?
No.
Sitting at home?
I think he will live with me if he gets very long with it. Or like stay 5 nights a week and then go home for a week and whatever. As well. So it's like middle of Kent, or like even more south than me. I live in the north of Kent, like on the campus, and he's in the countryside. Well, it's about a 40-minute drive from my house. So. They said I didn't even ask. They said like if he gets a job in London, I know probably commute from home. And he's like welcome to stay. It's not really much of a difference. He stays like a lot anyway. Every year I'm posting because I can't keep together with it. So if I had to, it would be like the weekend. No, not a massive rush, but it would be nice to have a house full of like the corner of the bread, I guess.
Where you do that?
Well, not by Lambda. Get like a 2 or 3 bed house near where I live. You know, never know it's going to happen. But, part of me was like, if I couldn't stand living back at home, I would have just raised in London, but I won't get them. I think it's worth it if I can. Yeah.
Do you live with your family?
I'm from Milan.
Oh yeah, I'm saying.
What did you say? I'm from Milan, so not useful distance.
Belfast.
Honestly, if you went from like Belfast City, that would be quite easy.
Well, you would do it every
To see
day.
of London, I guess.
Could you fit a jar?
Yeah.
My old used to commute from like Bath, it was ridiculous.
Every day.
Several like making hours. You would just like
Isn't that what that guy does? The guy that
Lady.
yeah, crazy. Nice beauty from like Wales. Is it Wales?
But he stays in London 4 days a week.
Okay. I'm in it all the
How did you do all this? How did you do all this? Is it a Wi-Fi? Don't even provide a microphone. Yeah, with listening devices.
So how, I guess people can ask questions on here as well.
So, go ahead. You go.
No, don't. Because it's less confusing chat.
Okay. Where's the chat? Questions?
Yeah, could be. Oh, let's just go to webinar. Which is a bit of webinar. Pass the show.
This how it works on.
Any objection to the session being filmed?
No.
I'm going to tell you.
Yes, I need to sign up to.
There's a, which the idea is you register and then gives you a link. That's quite nice.
Do you like it? I do. You? I didn't try that. No, yeah, he did. He's waiting. I know. He's been realistic too, like he's not expecting. This is kind of like what you know what I mean.
Did you get an interview?
And he's waiting to hear.
Huh?
He's waiting to hear.
Oh, so he hasn't heard anything yet.
I wonder how many applicants they have for the place.
Traffic
Depends on
light.
the job. And then like graduate ones, no experience, I reckon it's like
Yeah, they might get like
a way more than the experience high ones.
definitely.
Yeah. Yeah, it's a sensitive. So, Test, test. Hey guys, we're just sorting on the microphone and then we'll get started soon.
I hope everyone can hear me, including people remotely. Welcome to this session of BCS Spa. We had something like 25 people registered to come here in physical presence and something like 15 online. I think about just under half that number have actually turned up. But I'm really looking forward to this session because I get confused about terms like serverless and Lambda, and although I've done some work with Lambdas, I'm not quite sure what the distinction is, so I'm looking forward to finding out and how to use them properly. Just in case anybody's not been here, please be aware that fire exits and toilets are at both ends of this floor, so you can see an emergency exit there. There's toilets just to the right and at the opposite far end of the floor as well. If you do hear a fire alarm today, it's not a drill, so please evacuate the building. At the end of the meeting, the front door you came in by will be locked, so you have to go out the back door. And if you then turn right and cross the road, you'll see a place called the Coal Hole, where we often congregate after these meetings for a drink or two and to exchange views. Next month, March the 6th, is going to be a meeting, and Sohia has said that she'll try and organise somebody to talk about business transformation as a kind of antidote to the more technical subjects we've had recently. So without further ado, I'd like to hand over to Jan, who's going to talk about Lambda.
Thank you guys. Also, I'm trying to put the mic on the table so if you can't hear anything, please just shout in the chat window and you can go to webinar. I guess before we start, I just want to get a quick show of hands. I guess more for the people in the room. How many of you have used AWS and are familiar with AWS? Okay, I guess most of the room. Anyone's used a Lambda so far? About 2 hands. Okay, so actually, let me just quickly introduce myself first. So my name is Yan. I'm a principal engineer at a company called Zone, which is a sports streaming platform. Unfortunately, we're not live in the UK, but we are live in something like 7 different countries. And I think at this point, the public figure I've been told is about 6 or 7 million subscribers globally. So think of it as Netflix, whereby we pay a monthly fee and you can watch any sports that we have on our platform, so long we have the streaming rights for your country. And in the US, for example, we've just gone live recently with boxing, and at peak we get about 1 million concurrent viewers. So as you can imagine, there's quite a lot of interesting technical challenges there, having to build a system that can handle a large number of concurrent users, but also people that comes in all within like about 20 seconds before match starts. So as of last year, AWS also may be one of the community heroes, so basically people that goes around talking about serverless and try to sort of evangelize and share knowledge, and also do a lot of writing as well in terms of sharing a lot of things I've learned about serverless the last couple of years. One of the things I've done also is putting a lot of things I've learned in terms of what are the things you can think about when you're running a serverless architecture in production, and I produce a video course for many, which you can actually get a discount right now for, I think, 40%. I'll show the code later. With today, because it's a getting started session and we only have about 90 minutes, so I want to focus on just the basics, what Lambda is, how it works, and the things you should think about in terms of when you're running Lambda functions, but also, so as we mentioned earlier, what's the difference between Lambda and serverless? You might have also heard these names like function as a service. What do they all mean? And we're also going to look at one of the things that actually confuses people a lot, because there's actually a common framework for serverless called serverless. So when you talk about serverless, also oftentimes you also get confused in terms of what do we mean. But serverless framework is one of the most popular frameworks out there in terms of how do you take your code, package it up, and send it and upload it and deploy it to the cloud. One of the things that people ask me a lot also is, well, now instead of having applications, I've got all these individual functions. How do I organize my code? Do I put one function in every single repo and end up with 10,000 repos in my GitHub account and pay GitHub loads more money than I probably should do? And also just how do you deal with things like when you have infrastructure that is shared between different functions, between different aspects of the system, how do you handle those things as well? And if you've got time, I also gonna so you can see how we can deploy a demo app that includes some APIs, some Lambda functions, some Kinesis events and stream processing, and how all that fit together, and how we can do white test for our code as well. The good thing is, everything, all the exercise I'm going to show you is available online already. If you follow the link on this screen, that will take you to a GitHub repo. So I'm going to give you a few minutes, well, a few seconds to go and open it up. And also for the guys that have joined us online, if you've got any questions or anything that you want to raise for my attention, just put in the chat or the questions box in GoToWebinar as well. I'll look at them every now and then. Okay, has anyone not opened the exercise page yet? All done? Okay, cool. So in that case, I'm going to switch over to the exercise page as well. And for the exercise we're going to do later, you need to have an AWS account with an admin user so you can deploy your Lambda functions, but you should also have Node.js V8 installed or version 8 installed in the machine as well. And as mentioned, all of these slides are also available on the GitHub repo, so if you want to get my course later and you want to get a discount, there's a 40% discount code. So, if you look at some of the exercises we have here, we're going to start with what exactly is Lambda. Maybe I should probably start with a problem proposition of why did Amazon build this service in the first place. So coming back from my experience, having worked in the banking for a couple of years, back in the 2005-6-ish, I was used to sitting in massive meetings with 10, 20 people talking about how we're going to wait for the next 3 months and wait for servers to get provision added to our data center and have all the patches installed, and you have to take months before you can actually start to use it to serve our traffic. And then when I moved to another different startup, and at the time it was about 2009, we were using AWS already. So for me, that was just revolutionary. Now instead of having to wait for months to wait for this server to get added to our data centers, I just take a few minutes, and then a virtual machine starts, is there, and it's running my code. So, and then you also get this elastic scalability, where when traffic goes up, the number of servers goes up. When traffic goes away, the number of servers goes down as well. And that was great. Life was good. Life was never the same as before. But over time, you get used to it. And what you notice is that, well, even the phase that we have to do now in terms of having to set up servers, having to set up load balancers, or the scaling groups, and occasionally having to patch our machine image so that our OS have got the latest security patches and so on. Those things start taking more and more of my time. And I have a lot of things that I end up having to do is just babysitting and setting up my infrastructure, when all my customer wants to do is, please develop that next feature, I'm begging you. So for a long time, I always just wanted to have this thing whereby I don't want to worry about what web frameworks I'm doing. I want to stop doing the same thing over and over on every single project, setting up frameworks, setting up all these other things, configure servers and whatnot. And then when AWS announced the Lambda, it became quite obvious that's the thing that people have been having trouble with, and Lambda gives a very nice abstraction for the compute resources you're doing. But of course, having just functions that you can create in the cloud and run them doesn't really give you very much until there's a way for you to actually build useful applications with them. So that is where you can start to see Lambda being used with other services like API Gateway, so that you can very quickly, and we'll see later, how you can create an API with Lambda and API Gateway, deploy them, or also then you've got REST endpoint, or maybe if you want to do GraphQL nowadays, there's also an AppSync service that allows you to create GraphQL as a service without having to think about all the infrastructure behind it. And so here we have in the, so if I go back to my AWS console, you can see, you can find the Lambda service console if you just search for Lambda. And one of the nice things I always like to do is for services I use all the time, like DB and Lambda, you can click on this little widget at the top and pick the services that you want to add a shortcut to the bar at the top. And in this case, I use Lambda all the time, and maybe if I want to use, say, put Grafon up there as well, I can do that, or I can take things away. So now I've got a shortcut to go to the Lambda console. And here I can say, let's create a new function. From here, you've got a few things you can do. You can write a function from scratch. There's also a number of built-in blueprints for things that you can write based on templates Amazon creates. And more recently, they also added this new service called AWS Serverless Application Repository. Essentially allows you, as a customer of AWS, to publish your own functions so that other people can also just reuse them. So imagine how many of you have to write a function that does simple things like image resizing, translating from one image format to another one. It doesn't make any sense for every one of us to do this all the time. And the service application repository is a way for you to create applications that other people can reuse and parameterize. But we're not going to touch on that for now. So if you go back to the very basic example of how do I create a Lambda function. So in this case, let's say I'm going to create a function called hello world. And in terms of the runtimes, you can choose from quite a number of different languages, from the .NET Core 1 and 2, Golang, Java. You can also use Node, Python, and Ruby. And reInvent, they also announced a new feature that actually allows you to create your own runtime. So I'm a big fan of Erlang, for example, and I want to write my code in Erlang or Haskell. I can also create my own runtime, or I can use a runtime some other vendor has published, so that I can use the language that I want to work with the most. By and large, the most popular language on AWS for Lambda is Node.js. So your function, once you create it, you need to give it some permission. And within AWS, there's this concept called IAM, or I forgot what it's short for, but basically it tells you what you as a user or a role can access within your AWS account. So in this case, let me say I'm going to choose create a new role based on a template. I'm going to call the role, we call it BCS role. And there's a bunch of templates. In this case, I'm going to use a test harness, which actually gives me more permission that I need, but it's okay for now for the demo. I'm going to go ahead and create a function. And so now I've got a function that's created. We go over what you see, or what are different things you see on the screen right now. But one of the things you could do is I can actually just run the function right here in the console. When a function runs, you need to take its own input. In this case, I'm going to set up a test input, just call it test. And then I can say, let's run this function. So from here, you can see the output for my function. You can see every request, every time you run a function, the invocation has a unique ID, and you can see how much memory that function took, and how much resource, how much memory was configured with, how long did that invocation took, and also, interestingly, our function ran for 18.44 milliseconds, but we got billed for 100 milliseconds. And that's one of the key things to remember about Lambda, that even though you are only paying for your function once, the actual amount you're paying for is determined by how much time you run for, as well as how much resource your function is configured with. A function with 256 meg of memory is going to cost you twice as much per 100 milliseconds of execution time as a function running 128 meg. And your function, even if it runs for 1 millisecond, you're still going to get charged in 100 millisecond blocks. So when it runs for 101 millisecond, you're going to get charged for 20 milliseconds. And every time your function runs, you also get a bunch of logs as well. These are all system logs, so things that the Lambda runtime publishes for every single invocation. You can see what version is running. We look at more detail, the unique request ID, also all the things that we see above in terms of the duration, how much time you got billed for, and so on. So down to our actual function itself. So Amazon bought this company called the Cloud9, which builds the online IDE, so they're integrated with the Lambda console, so you can actually enter the code right here as well. So if I want to say, I want to log some message, and I also want to say change the output for my function to, instead of just saying hello from Lambda, I'm going to say hello from BCS. And I can actually save my function right here, there, and then run the function again. So now if you look at output, it's going to say hello from BCS. So going further down, every function can also, you can configure every function with a number of different environment variables. So for example, if I set environment variable full and bar, then I will actually be able to access that from my function's code. So if I say, in the case of Node.js, I can access that through process.n. In this case, we call it full. So if we save this, test again, you can also see the console output from down here as well, that we were able to access and print out the environment variable we set here. And oftentimes you find people is going to put things like API keys and credentials and so on in environment variables that you can pass those secrets into your application, your code, but you don't want them to be showing up in plain text in the console. So what you could also do is enable encryption using the KMS service, which is the encryption as a service that AWS provides, so that you can encrypt them in the console. You can also tag your function. So if you go back to the Lambda dashboard, imagine now you're going to have hundreds and hundreds of functions. How do I quickly find the function that I'm looking for? Maybe I'm really only looking for functions that are managed by a particular team, or I used to implement a particular feature. So that's a good use case for tags, where I can say the team is going to be, you've got a team in the zone called Kunas, and you may say the feature is the user service or user API, and you may also have a name for a service as well, whatever, or PCS, and so on. It's becomes very useful when you have many functions running in your environment to be able to very quickly find functions that you're looking for. We already saw how we can create roles for our function, and you can set a description. But the two most important configurations for a function is how much memory you give it, and also how much time your function can run for every single invocation. The maximum timeout you can set for invocation for function is 15 minutes. So anything longer than that, Lambda service is going to time out your function, even if your code is still running. And one important thing to remember about setting memory is that even if your code is that the amount of CPU resource you get and the amount of network bandwidth you get for your function is tied to the amount of memory you allocate. So a function that has got, say, 1 gig of memory is going to cost you more, but it's also going to have a lot more CPU. So when you're doing CPU intensive work, or if you're running, say, Java, .NET Core, whereby to initialize the actual runtime itself can take a bit of time, which is why the first time you run a function, it's going to take a bit longer than the next time you run it. And that's what we call a cold start, which is basically what happens when, say, Lambda receives requests to please run this function. And it's going to see that, okay, I don't have any containers running. Imagine under the hood, it's still running containers. Now I need to find the locations in my fleet of servers to create a new container. And then I need to have to initialize the runtime for the language for Node.js and for Python. Very little work to do there, but for Node.js or for .NET Core and for Java, that's pretty heavy runtime that you initialize. After it does that, you still have to initialize your code before it's then able to invoke your handler function. And if your function needs to access anything inside of VPC, which is a virtual private network in AWS, then you also need to give it access to your VPCs as well. Another thing that to keep in mind is that as of right now, when your function needs to have access to VPCs, when a new container is created, AWS also have to check, do I have an ENI available for this function, for this container to use? If not, I need to create a new ENI that can give it access to anything that's running inside that VPC, which means that's going to increase the invocation time for that invocation, which is again something that increases your cold start time.
I don't think anybody's familiar with the term VNI. I use the term virtual NIC, but is that what?
So ENI is basically the way Amazon implements VPCs right now. It stands for Elastic Network Interface. So imagine, so with VPC, what it does is that it stops traffic from going into whatever's inside VPC, decide anything that matches your inbound rule, and then it stops traffic from going out. But it does that by having these network interfaces that inspect the traffic and then checks whether or not the traffic is compliant with your network rules. Which means when your function needs to be protected by a VPC, it needs to have that ENI created for the container that it's running on. And another thing to keep in mind is that when your function runs, what happens if it fails? And when you're using event sources like SNS and other async event sources, there's built-in retry. So that's actually I'm jumping the gun here. When your function, when you're just sitting there, you can run it. That's great, but it's not very useful. How can I use this to build an API? So that's where you can create triggers for your function. So for example, if I want to have an API gateway that when I hit some URL will trigger a function to do something and then return a response, then you can set up a trigger with API gateway and configure that in the console. It's been tedious, but we look at how we do that using the Serverless framework. But equally, I can have my function react to whenever something's been logged in CloudWatch logs, or whenever some events be triggered by CloudWatch events, which is a very good way to create a cron job using CloudWatch events and set up a cron expression that will trigger your function based on some schedule. Usually, you can say, whenever something gets put into S3 or someone deletes an object in S3, please trigger my function to do some processing. Or whenever someone publishes a message into SNS or Kinesis stream and so on. That's all many different triggers you can use, and this is actually not a complete list on the console. And for things that are asynchronous in nature, things like a message that goes into SNS and then Lambda try to call your function to handle that message, if you get 3 retries out of the box, and then if it still fails, at the end of that, then you also have this way, a way to capture those failed invocations using a dead letter queue. And finally, you also see this option to set the concurrency. So a lot of people look at this and think, oh right, there's a concurrency limit on Lambda, and there is, the default limit is 1,000 concurrent executions of all of your functions inside the same region, well, per region, per account, but that's a soft limit. One day you can actually just go to the support center and ask for a raise. So I can create a case to say, AWS, please, I need to run more concurrent executions for my Lambda function. For Lambda, I have to choose which region as well, so let's go to London. You can raise the limit for the amount of the data cold storage, which is how much, there's also a limit on this, on how much deployment artifact Amazon will store for you, which is default is something like 75 gig, but you can raise that. But the most important one is this concurrent execution. So all you have to do is choose a new limit and also give them a use case. Why do I need to have 50,000 concurrent execution of Lambda functions? So the default is 1,000, but you've got companies like FSA in the US and also Bouncer in the US as well that are running at something like 50 or 100,000 concurrent executions. So there is no really hard limit on what's the maximum concurrent executions besides what you're willing to pay for. The second thing to notice here is that what's this reserved concurrency? The name suggests that means if I set 3, that means there will always be 3 instances of my function running. Unfortunately, that's not how it works at all. In fact, it's the opposite. When you set a reserved concurrency, this becomes the maximum number of concurrent executions for your function. The reserved concurrency refers to the fact that by default you've got a pie that's got 1,000 slices, and I want to reserve 3 of that slices for my function, and that's the only string that you ever use, and hence the name reserve concurrency. It's terrible, but they can't change it. And we've run our function a couple of times now. All the logs are going to go straight to CloudWatch logs, but we also get a number of metrics out of the box. Again, with CloudWatch, you get metrics around the invocation, the number of invocations, the invocation time, number of errors, number of throttling, and the delta queues, and so on. And if I want to see the actual logs, I can also follow the link to go to CloudWatch logs, where you can see that every time I create a new version of my function, or a new container runs my function, there's a unique instance of CloudWatch logs stream for that particular container. And inside that, I can see everything that's coming out of my function. Anything that I write to send out gets captured and shipped to CloudWatch logs asynchronously. So I don't have to install any agents, or in fact, there's no way for me to install agents, so I get log collection out of the box, which is quite handy. Where it falls down is that CloudWatch logs doesn't make it easy for you to search across all the logs you have for all of your functions. So one of the things that I talk about in my course is how do I then apply an Lambda function to essentially say, whenever anything is logged to my functions, please ship it to somewhere else. And you can actually do this in the console, or do it through Terraform or CloudFormation and say, for this log group, please stream it to Amazon Elasticsearch service. If you want to use a managed Elasticsearch, or you can actually stream it to a Lambda function.
Supposing you're trying to use a tool such as AppDynamics.
So tools like AppDynamic and Datadog and pretty much everybody else, they all support ingesting metrics from CloudWatch. And that's what we're doing right now. We have integration set up between for our AWS account for Datadog. So all the metrics coming into our Lambda function gets ingested into Datadog, and that's where we set up all of our dashboards and alarms and so on. So there's also a couple of things I want to sort of touch on in terms of the basic concepts around Lambda. Another thing you see here is that this thing you can set up to view tracing X-ray. We're not going to touch on X-ray just yet, but X-ray is basically a distributed tracing solution that allows you to see so if your function is talking to DB, is talking to something else, they can see how much time within one invocation, the invocation ran for 100 milliseconds, of which 30 milliseconds went to the DB operation, and then the 20 milliseconds went to when we call some internal API and so on. So you get a lot of tools out of the box. They are, so as Amazon always are, they are very good at meeting the basic needs for users. They're not very polished solutions. And you typically find that most people find it okay to use just the CloudWatch and X-Ray when it's getting started, but as their architecture becomes more complex, they also find that they just can't use AWS tools anymore. And they also added this, sorry.
If you say they're kind of rough and ready kind of tools, what would you use if you wanted more refined?
Yeah, so the more refined tools that include some of the things that you mentioned already in terms of AppDynamic, in terms of Datadog, but also there are a number of vendors now that's come up that are focusing specifically for serverless. You got quite a few of them. AeroPy, for example, is one of the early adopters, or sorry, earliest vendors in this particular space. We also have that's probably a list of somewhere. There's also Dashboard. One of the very nice tools I found is this guy's called Hexagon. What they offer is the ability to trace invocations at the user transaction level. For example, when you have got loads of functions, I don't really care if individual functions are operating well, because I care about at a high level when the users try to sign in, what's latency they feel end to end, and how many of those user transactions actually fail. Even if one of the functions has actually failed, if I'm doing my job correctly, then the rest of the architecture is handling those error cases and retrying them. So I've got resilience. Again, it's quite a common thing that you find in the microservices, that individual failures shouldn't bring down the whole system. And so what I care about is at the user transaction level, what are the health of those user transactions? And Hexagon and other companies that are also entering this space quite new, called the Vigo, they both offer this idea of tracking the health at the user transaction level. And what Lumigo also does on top of that is reporting the cost. So one of the really powerful things you get with serverless and with Lambda, and the fact that you can find that you're getting charged based on every single invocation, is that historically, I have no way to figure out for one particular application what is the cost of individual features. Because I've got one server that runs the whole damn thing, or I've got one server that are implementing one service, and that service is used by 100 other services to implement different features. I have no way to allocate the cost to individual features that I'm developing. So I've got a business, a product owner comes to me and say, we've got this brilliant idea, it's going to make us loads of money. You can probably track, we are very good as an industry to track revenue. We are very good at attributing revenue to different streams of features, but we're really bad at figuring out what is the cost of running that feature. And when you're talking about return on investment, you have no hope of calculating that unless you know both the return and the cost. And the original cost is super hard to figure out when you've got this one thing that gets used by 100 different things, you have no way to attribute cost. But for all the services you find in AWS, Lambda invocation is a compute layer that allows you to figure out, to tell you the cost per transaction. At the same time, things like API gateway is, again, based on request count, and same with DB, same with SNS. So even if I've got this really complicated system that spans across many services, I can still work out. So long I know what are all the different things that are being touched on by one transaction, I can work out aggregate cost for individual transactions. So I can see, okay, for this new feature you're building, it's costing us X amount per month to support, and you're generating Y amount, and when Y amount is less than X, that means it's costing you more to support this feature than to actually run it.
And that's what Lumigo does.
That's one of the things that Lumigo does. There's also other vendors that are entering this particular space.
But Lambda doesn't do that.
Sorry?
Lambda doesn't do that, or does?
Lambda doesn't track the cost for you, no. You can find out how much the whole Lambda service costs you at the end of the month through the AWS billing, but you can't find that at the transaction level. Well, I guess you could. You can work it out yourself, because whenever you run it, you find out how many times you got billed, and you know how much memory got allocated, and you know the cost. Okay, so
the first time you start is going to take some time.
Yeah.
So that means if your service is used frequently, it's going to cost less.
Not necessarily. So CodeStar happens every time a new container is created, but that container is reused. So if say I hit an API once, okay, it's CodeStar. Second time I hit it, it's warm because the container is really thin.
Yeah.
And so the more you use it, potentially it will be cheaper. But then again, those containers doesn't just live there forever. One of the benefits of serverless is that you can actually scale to zero. So when traffic goes away completely and no one's using your service, then the container gets destroyed. You have zero container, which means next time someone says, I want to hit the endpoint, you can't create a new container. Equally, when traffic goes up, the number of concurrent requests going to your service increases. You also need to have more concurrent containers. So you can't just rely on having more traffic, because it really depends on the traffic pattern.
Right. I think the point was if your service gets used frequently, then the cost per transaction will probably be less.
Probably, yes.
General question: when you mention scale to zero, people think the scalability is going bigger, but is the scaling downwards or to zero used as much, or but people don't think about it?
So the question, I guess I've got to repeat the question. So the question is, scale to zero is great, but do people actually use it? Because most of the time when you think about a scalable system, you think about scaling up, right? But the whole elastic scaling scalability is where if my system is not running, no one's using it, why do I want to pay for peak traffic? So that elastic scalability has always been there with EC2, with containers now as well. Even though with containers, arguably it's harder, because a common question people ask me is, what do you guys do with your ECS cluster when you scale to X number of servers? And those containers are services, right? They need to keep on running. How do you scale down when there's going to be something still running on that server? I can't scale it down completely. We don't have a good solution for that. Right now, we kind of just set a maximum on the services, and that's quite a common thing people do. So you end up still paying for the maximum peak load quite often. Whereas with serverless, Amazon just does that for you, scales to zero when nothing's happening.
And that's effective. I mean, that's useful to know, but people maybe don't think of doing that. It's like spring cleaning in my view. They scale to 0 to help get rid of old things.
Yeah, and also it also means that Amazon can actually allocate resources, manage resources better across all of its customers, rather than everyone running hundreds of servers all running at 5%. Amazon will be managing maybe 500 servers, but then everyone can just use them when they need to. So it's actually better for the I haven't talked about this very enough, but it's probably better for the planet as well, just in terms of improving the efficiency of data centers.
Your function runs at thread level isolation or process level isolation?
So the question is, what level of isolation does your function runs at? I am not sure. So, and that's also changing because one of the things that Amazon found, well, right now, Lambda doesn't run on containers at all, it doesn't run on Docker. Pretty much all the other platforms you find, they run on Docker. What Amazon found is that with Docker, there's just not good enough isolation that they can't trust it. So what they've done right now, I don't know exactly what level of isolation they're running at, but they don't run different customers' function on the same server. So one server would be used to host containers for one particular, for just one customer. So there's no multi-tenancy. One of the things that NASA reinvented last year is this new thing called Firecracker, which is a replacement for the virtualization layer, which I think right now, I can't remember whether it's Zen or something else, but the Firecracker is a replacement for the virtualization layer, which gives them better isolation, so that in the future, they can actually do multi-tenancy across the customers.
Basically, this function, small function, is running in a separate instance.
No, so if I've got 100 functions, any container that gets created for those functions will not be shared, will not be running on the same server or on any server that someone else is running.
So it will be a server instance. This function is running on a server instance.
You'll be running on a server somewhere, yes. But
that server is shared.
It's shared within my account, yes.
It's a virtual server.
Yeah, it's big VM, but not shared with other people.
No, so the VMs are not shared across multiple customers. So that's one of the things that Amazon is doing to make sure that given the weaker isolation level we have, at least you can't compromise someone else's account. So I think I'm actually running really behind. So the next bit I want to get up to is how to actually do deployments with the question of break, by the way. Also, the exercise are all online, so if you guys couldn't get through them, you guys will also try it out afterwards yourself. So the serverless framework, as I mentioned, is one of the most popular, actually probably is the most popular deployment framework for Lambda, and for serverless. And they actually support different platforms as well, so they're not particular to AWS. You can also use them to deploy Google Cloud Functions or Azure Functions and a bunch of others as well. I think right now they support 8 different providers. So I've got the server framework installed, so in this case I can make a directory, let's call it hello DCS. And I can create a new project called using SRS create template. In this case, there's a whole bunch of different templates. If I don't provide it, then it's going to shout at me. And for the error message here, you can see that there's a whole bunch of different templates that supports different providers, but also different language runtime as well. So in this case, let me just enlarge this so that you guys can see. So I can create a new project using the serverless framework. So all of these exercises, you guys can actually follow along on the repo as well. But in the interest of time, I'm just going to show you how this works. And okay, I created a new project. So that question I sort of raised earlier in terms of how do you organize your functions, you don't want to have one repo per function. And in fact, when it comes to Lambda, we're not thinking really in terms of individual functions. We still want to think in terms of service boundaries. Okay, I need to build a service that can allows me to implement some particular feature from business requirement. And the server framework also provides this this concept of the service, which is essentially a way for you to group multiple functions together. So if I call this one hello DCS, it's whole bunch of different configurations. In this case, we're going to use AWS Lambda, so the provider is AWS, and the runtime is Node 8. I can configure what environment, what name I'm going to give to my project, to my deployment, and what region I'm going to deploy this to. Defaults is dev and US East 1, but we can override those. And also, I can create, I specify what permissions an IAM role. Did you guys see the back? Yeah. Cool. What permission the IAM role will have. In this case, I can say my function will have access to DynamoDB. They can read from it, they can write to it, and that, to a particular DynamoDB table and so on. And I can also specify environment variables that can get applied to every single function in the project. I can also customize what goes into my deployment package and so on. And down here, I can specify multiple functions. And after I set up a function, I'm going to leave just one right now. After I set up a function, then I have to say what are the event triggers, what are the service triggers for my particular function. So in the case where I want to build an API, with API Gateway and Lambda, I can just say there's going to be an API endpoint, user create, it's going to be a get. Well, it's not going to create then, is it? And additionally, if I've got the things that are particular to this project, and we're going to talk about it later, things like S3 buckets or DB tables that are only used by the functions inside this particular service, then I can also include them as additional resources, and I can specify them here using the same CloudFormation syntax.
Can I clarify? What you're doing now is basically what you did in the console previously, but you're doing it as a script.
Yes. So.
And what is the path user? Shouldn't that be something like greet?
Sure. It could be greet. It doesn't have to be whatever.
Well, I was going to say hello.
Sure. Or it could be the root as well. In this case, the handler is a path to. So in this case, it says handler, which points to this module, Node.js module. And it says hello, so handler.hello, and hello is the name of the function I'm exporting. So if I change this to handler, then the path will become handler.handler.
Okay, yes.
Right? And because it's Node 8, I don't need to use the use strict. This is a similar structure that we saw earlier in the hello world example we had, but we don't have to return this. Our function can actually return pretty much anything. In this case, I can just return some string. I can save, I can test it, it still works. So this particular structure is to satisfy API gateway. So imagine a request comes into an API gateway, an HTTP request. It's going to forward that to my Lambda function, it's going to call my function, and then it's going to somehow have to take the response to my function, which is what I'm returning here, into a HTTP request or response to the caller. So this particular object, this particular contract is how your Lambda function can tell API gateway how to translate my response into a HTTP response. In which case, I need to specify the status code as well as the body for my JSON payload in this particular case. So if we say message is hello from BCS, now I can actually deploy this. I've got multiple AWS accounts set up locally, so I'm just going to export the AWS profile to personal, so I don't deploy it to my work account. And then I can just use SRS or Serverless for short. Once you install the Serverless framework locally, you say SRS deploy.
Yeah, people joke that in the language Rust, the hello world takes about a megabyte of memory, but this one obviously takes more.
Megabyte of memory. I'm not sure. Node is actually pretty small, the package size normally.
Do you have other access to other requests, things like query string or?
Yep. So actually, I got rid of that earlier. I should have just kept it here. So maybe just talk about behind the scenes what's happening. So the server framework itself is actually just an abstraction layer on top of CloudFormation. So under the hood, it's actually using CloudFormation to upload it. So in this case, 272 bytes. So it's actually quite small compared to Rust in this case.
Right, when it executes.
Oh, right, yes.
Yeah, we've got 48 megabytes or something.
Yeah. So, one under the hood, what the Serverless framework has done, I do like Rust very much, and you can actually use Rust nowadays as well, because I think there's Rust runtime someone else is working on, or you can use a Sheen, like a Node or Go Sheen to run Rust. What the Serverless framework has done is translated the resources that are provisioned in the server, for example, into actual resources in CloudFormation, including the IAM role, the Lambda function, which tells me where the different artifacts are, how much memory to allocate, what IAM role to use, as well as the actual CloudWatch logs, groups, and API gateway as well in this case, which is one of the things that I also always find that with API gateway, even when I've got a very simple URL like this, it turns into like 10 or 15 different resources I have to provision through CloudFormation, and the serverless framework just kind of abstracts a lot of that complexity under the hood for API gateway. And you can see straight away there's quite a few things that's being provisioned for API gateway to support that very simple endpoint. So I can now deploy my code. I can actually curl it and get a response back. In this particular case, we just make a change to the function to include to see what the input was, to see where we can get the query string parameters and whatnot. I can actually do SRS deploy and just say I just want to deploy the function, which should be a quicker, more efficient deployment. Well, in this case, upload the function. Okay, it's done. So now if I refresh, you can see that I'm actually getting back the payload that's gone into the event object to my function, which as you can see, has got a whole bunch of things, including the resource, the path, the HTTP method, the header that's come in, and the query string parameters when it's provided. So if I say message equals greet, then you see the query string parameter is there you go. It's there. And I can also implement authentication and API gateway layer by saying, okay, this function should have authorized, it will be using IAM, so that whoever calling my function needs to sign the HTTP request with the AWS V4 signature, or I can use a cognito service and a number of other things as well. And when I do that, identity will be populated, and I also get things like the domain names, which is something that is the domain name for the API gateway deployment. So far, so good?
Yeah.
Cool. So I know I've been talking a lot, and do you guys want to take a few moments? Actually, maybe I can show you one more thing as well. Is one of the things you can do with the serverless framework is you can actually invoke the function locally as well, and it supports Node, Java, Python, and I think Ruby as well. Maybe not Ruby. So I can actually run SRS invoke function hello. I might have got syntax wrong. Yes. So in this case, I can actually invoke the function directly locally if I want to just check that it's running. It's just useful to I can also do things like is it logs?
So when you're saying invoke locally, does that mean it executes on your machine? Or
yeah, so it just takes this code, it just takes my Node.js code and just runs it locally. But it's going to execute it with in this case, my default AWS profile. So if my service, my function is talking to other AWS services like DB and whatnot, then you use that default credential to access it. And you can also invoke the function. Sorry, I think this one actually invokes remotely. I can do this invoke local, that's it. I thought I did something wrong. When you invoke local, you can also pass the data. So in this case, if I just want to pass some JSON object, message, hello. there's our input. So previously, you can see the input was nothing because we just coded it without any data. So this is quite useful for me. For example, whenever there's been an error in production, I can I can make sure that my functions are logging the invocation event when there's an error, so they can go to my Elasticsearch or whatever, Kibana, or whatever, to grab the invocation event and then replay them. I can also capture example invocation events so that I can also use them as part of my test or just to see how to just run my function locally. And because it's something that I can run locally, I can actually set up a debugger and it's also set up a debugger as well to run the SRS invoke, to launch the serverless. I can't remember the path, but I've got a blog post which I can share to basically hook into the local invocation, so that I can also test and debug my function and step through the code locally as well. So it's not the same as running the whole thing locally, but there's also other plugins for the serverless framework, but also for Amazon's got our own AWS SAM framework as well, which one of the things it also supports is being able to run API gateway locally, so that you've got a local endpoint that you can hit. But since I can just invoke the function locally like this, I can look at JSON response, I can basically work out what's going on. But what I can't do is, if I'm doing server-side rendering, I can't just look at this and see magically what does the HTML actually renders like. So where that becomes useful is when you want to host API gateway locally, so that you've got an endpoint that you can hit to see from the browser to see the HTML response coming back and see what that is rendered in the browser. But other than that, most of the time I don't need it. I find that the SRS invoke local is does a good enough job for me. So let's have a look at what else is on this exercise. You can, so you can also customize a whole bunch of different behaviors. But once you're done, you can also just say SRS remove, and this would just delete everything that's been allocated, all the resources that's been allocated, so you don't have to have all these things that's running in your environment, even if they're not costing you money anyway. So any questions?
I think we need to actually do something.
Yeah, so I know I've been talking too much. Please go ahead and give this a try, follow this through this exercise.
So anybody wants to do this together?
This is more suitable for processor-intensive tasks. I think it is more suitable for processor-intensive tasks.
So I guess the question is, what is it most suitable for? I would say most things, but there are a few things that is not particularly good for right now because of some of the platform limitations, which I actually wrote a blog post on recently. So essentially, one of the things that is not particularly good for is when you require consistent and very high performance. That's mostly because of when you consider the fact that you've got cold start, which in practice, even though for the hello world example, we have no dependencies, our code is super light, so cold start is going to be like in order of tens of milliseconds. But in practice, by the time you need to require the AWS SDK and all these other different things, you're probably going to see anything between 100 to 500 milliseconds for Node.js functions, and for Java and .NET Core, you're looking at anything between 3 to 7 seconds. And then when you've got VPCs, then you're really screwed at this point because that can just on its own add 10 seconds. I've seen functions that's got 17 second cold start because it's running on Scala and it's inside VPC. In which case, it just destroys a lot of use cases. But even without that crazy cold start time, it's looking at maybe half a second or a few hundred milliseconds cold start time, which is good enough for most web use cases. But there are cases where it's just not good enough. I came from a gaming background where we were building real-time multiplayer games, and we're talking about response time needs to be sort of single-digit milliseconds, and that needs to be our sort of 99 percentile on and so on. So for cases like that, no, Lambda is not good enough right now. There are a few other platforms, other companies that are providing, I guess, functional service in this case, which is running a function in the cloud, someone hosting it for you, that are designed for the sort of high performance scenarios. So Binarius is one. There's another company called the Nucleo, which also offers you, I guess, the function abstraction on top of Kubernetes cluster, and they also have a managed offering, so you can use it kind of like Lambda, but it's more geared towards high performance, the high throughput scenarios. Also, when your function, because it's all based on event trigger. Something happens, your function runs for once, and then it goes away. It doesn't run again. So it's not designed for consistently long-running processes. So where you've got, say, a server component, you're implementing a WebSocket server, that server needs to be running all the time. That, again, is not something that you can do with Lambda today. Or when you're talking about systems that are literally seeing tens of thousands of requests per second. In terms of Lambda, you pay per invocation, and if everything is fast, you don't pay a lot. But when you're talking about high throughput like that, that cost can still be a lot more expensive than if you just pay someone to actually run a cluster of server for you. In which case, the economics of the pay-per-use model start to sort of go against you. But you're talking about really, really high throughput systems. Otherwise, most of the time, paying someone to look after the infrastructure for you is going to be way more expensive than just paying more for Lambda. You're talking about hiring an engineer, a DevOps engineer, you're going to be looking at a couple £100 a day. So there's a lot you can do with that couple £100 a day to just run, just give it to AWS and run it there. And the last thing is when with Lambda, you get really good built-in resiliency in terms of you get multi-AZ out of the box. But if you want to do a bit more, because a lot of time when you're processing things like from Kinesis events, there's a lot of things that are, the state of the poller is inside the Lambda service itself. So you can't just take that state and move it somewhere else. So in which case, when you need to have a stronger, more built-in redundancy, but you can't rely on multi-region, then it's also not good enough. So specific cases, then it's not good enough, but in the general use case, APIs, background processing, cron jobs, whatever, they can all work with Lambda.
So it takes .NET or Java runtime about 3 to 7 seconds. The only real choice probably is Node.js.
So Node.js, as I mentioned, is looking at in production. I see anything between 1 to 500 milliseconds. Most of the time, I see closer to 500 than least to 100. So
Node.js is the only real choice. Node.js.
No. So Node.js. So if we can look at the language runtimes we have. Okay, I can show you here.
No, I can see the runtime, but you can't wait 7 seconds for .NET to fire.
No, you can't. At least, well, depends. For background processing, you don't care, right? For background processing, it's not user-facing latency, so you don't care if it takes 10 seconds, so long as it's within reason. But for APIs, for things like user-facing, of course, 3 to 7 seconds is just ridiculous. But for Node, for Python, and for Go, you're talking about half a second as code start time. And that's before you do it more aggressive optimization, which you can bring them down. I have seen Java functions that code starts within about a second, but even that second is still quite a long time for user-facing APIs. So if you're concerned about code start time, I just say don't use .NET Core, don't use Java, at least until the platform improves enough, or use a different functional service that's not Lambda. So, I forgot to address the question that was asked right at the start, which is what's the difference between serverless and functional service and Lambda? So serverless, normally when we talk about serverless, it just means things that you don't have to manage a server, so I'm not working at the abstraction level of a server. Container, sure, you're not really talking about server, but you're still talking about opening ports, you're still talking about loading code into particular paths and all that stuff. So you're still talking about a concept that's very close to a server. And for a lot of cases, I still have to manage the EC2 cluster under the hood. So someone, maybe not myself, but someone in my team, still have to manage the underlying infrastructure. So when we talk about serverless, most of the time I think about it as something that I just don't have to worry about this whole abstraction layer of a server, whatever form it may take. But also with Lambda and many other services, we're talking about things that are, when no one's using it, I'm not paying for it. Because again, paying for uptime is a very, very server-centric view of the world of how to get charged. So things like S3, that's actually you can consider that as a service as well. Because again, S3 scales automatically. I don't have to think about the server. I'm not dealing with storage. I'm not dealing with stuff that I pay for when no one's using S3. Same with Amazon's Athena or Google BigQuery or DynamoDB in this case as well. Whereas a functional service, we're talking about services that allows to write your application using the abstraction of a function that you can deploy and scale as a unit of a function. So there's a lot of overlap that the most common people think about function service or serverless, think about Lambda because it's kind of the most popular one. But the two concepts it's not exactly the same. There's a lot of overlap. You can also find things like Knative, for example, that allows you to run your own functional service abstraction layer on top of your own Kubernetes cluster. But if you're running Kubernetes yourself, to get that, then you still pay for that Kubernetes cluster when no one's running any functions. So that's the answer, at least my answer to what's the difference between Lambda and function service versus serverless.
We did find, when I did an exercise in Lambda about 8 months ago, we were using Kubernetes cluster in AWS, and we found that the auto-scaling simply didn't work. You had to, if you wanted a maximum cluster of 3 nodes, you had to size it at that to start with. So it was completely non-flexible.
So that's EKS?
That was, I can't remember.
Is that the Amazon's Kubernetes cluster?
Yeah.
Okay. Yeah. That's the EKS. Yeah, EKS is quite new. It's quite raw compared to Google's GKE and Azure's AKS. I think EKS still got some way to go. Amazon really want people to use ECS, which is their own sort of container scheduler, but I think the battle is really lost. Everyone in the industry just wants to use Kubernetes. And I'm talking about container orchestration.
I'm trying to work out where I added.
Yes, sorry.
Okay.
How are you guys getting on with the exercises?
I've got as far as running the service locally.
Okay.
Add it at the end.
Now I need to do the configure a default profile.
Okay. So you've got the AWS SDK set up already. You probably have this. Hopefully you have this configured already.
Actually, I've got active key ID and active secret key ID and all that
Okay,
stuff.
cool. Yeah, so you have those, and you can just run AWS configure and set up a profile, or use a set up default profile.
Do you remember to?
So what's the question?
It's packaging it and stuff.
Okay, cool.
Just like when you did it, it's taking forever.
Yeah, the first time you deploy, it also takes a bit longer because there's a two-step calculation. The first one because it uses S3 to host the deployment artifact. So you've got nowhere to upload stuff to until you create the S3 bucket. So it does this two-step thing to first create a stack with just S3 bucket, and then you upload the artifact, and then do a second deployment update step to then actually deploy the function itself. But still, it's way faster than having to provision a server, set up a cluster, and all that stuff.
Oh yeah. This used to take days.
Yes.
I found actually using Vagrant was a very nice way to instantiate machines, virtual machines in AWS. But I guess this supersedes that.
Yeah, so with things like a Vagrant and I guess Docker as well, is they provide a level of abstraction that's nice to work with than the raw OS itself. There's all kinds of different things that's easy to become to give the cloud where it's contained with Docker. You can say exactly what it is you want. But at some point, someone still has to manage the serverless. Someone still has to manage EC2. So that pain still have to be felt by someone. And also with EC2, even with ECS, container scheduler, you can allocate containers very easily and quickly, but that's only until you run out of resource or spaces in your cluster. So you've got 10 machines, so that's ultimately that determines the number of containers you can allocate or how quickly you're able to scale the number of containers. At some point, you're going to hit the maximum in terms of how many spaces I have. So when you hit that, guess what? You have to wait for each 2 server to come up in just a couple of minutes. And with Lambda, there is a scaling limit in terms of how fast the number of containers you can, AWS will be happy to spawn for you per minute, which right now stands about 500. But for most use cases, you're going to find that because containers are reduced, you're never going to get anywhere near that 500 limit. And even to sort of match that same speed, that same sort of rate for yourself, you're going to have to run a massive cluster with a lot of empty room all the time and paying for them when no one's using it, just so that at a moment's notice, I can scale up to whatever I need. Some of the other platforms I mentioned, like Binaries and Nucleo, they have there are more options in terms of being able to specify the number of containers I should always be running for a function, for instance. So they do a few things where you've got specific use cases that are not a good fit for Lambda, like the ones I described earlier. Then there's also other options that you can go for as well, if you really want to go with the functions of service abstraction.
Okay, well, I've deployed, I've hit the endpoint and came back with event stuff that I embedded, so I know all of the things that were passed into the handler. And there's really quite a lot to be working with, isn't there?
Yeah.
When you return HTML back, what happens if you just cache? Caching around a cache for a few seconds or minutes.
Yeah, sure. You can do the caching in API gateway.
Who will cache it? Is it Amazon or your function will cache it, or who will cache it?
So the question is around caching. You can do caching at different layers. So okay, maybe I should just deploy this again so that I can show you. So remember, we are provisioning an API gateway here, and so that gives you some endpoint. So the first layer of caching I can do is at the edge with CloudFront. I can actually create a CloudFront distribution that says that points to my API gateway URL as origin. So that's my first layer of caching. The second layer of caching I have is in the API gateway itself. So API gateway gives you the option to configure caching for the whole API endpoint. You can configure which of the sort of power parameters, which of the querying parameters and headers gets included as part of the cache key. And then you can also do more sophisticated caching at that layer. But then even when you use your function, you can still do additional caching. So one of the things I haven't talked about is the fact that your function is not entirely stateless. So as you can imagine, if you're working with something like RDS, it doesn't make sense for you to create new database connection on every single location. So what you could do is anything that gets the same way that if I'm using AWS CK, it doesn't make sense for me to be creating an instance of the client on every single request. So anything that's declared in Node.js outside of your handler function in the sort of global, those gets persisted as part of the state of your container. So in this case, I'm creating, say, DynamoDB client, new AWS, DynamoDB. I don't have the IntelliSense because I don't have the package yet. DB.document client, whatever. Then this object is still there the next time a function runs. So when I have, if my connection pool is declared outside of my function handler code, then they get reduced. So I get some caching in this level, but I can also just use something like Elastic Cache or Redis or whatever to do application level caching if I want to do that. So again, I've got multiple layers of caching that I can leverage. Most of the time, I find that I don't need to do anything beyond just Cloud Front caching or API Gateway caching. So if I go to API Gateway, I think I've deployed to US East. Yes, US East. So the Virginia. I've got a bunch of functions here already. This is demo. So in this case, I can turn on caching in API Gateway level. I can configure the cache capacity, which I'm going to be paying for. Essentially, API Gateway is running a memcached instance, and I'm paying for time for that memcached instance. I can control the time to live and all that.
So things declared outside your function, they are shared within your functions.
Not shared between functions. It's shared between locations to the same instance of my function. So imagine it's just a state inside container. It's the part of the Node.js runtime. You can't stuff that's declared outside here is not shared between instances of function. In the same way that containers, when there's some internal state, is not shared between containers.
So if two requests come, one after another, they will use the same invocation.
As much as possible, yes. If it's right after each other, then chances are you'll use the same container. So API Gateway, essentially when the request comes in, API Gateway says, hey, Lambda service, please run this function. And then Lambda can see, do I have something that's free, a container that's free? Then if I have, then I'm going to use that one. But if it's already running, it's doing some other handling, another concurrent request, then I'm going to create a new one, and then I'm going to forward the request to that new container.
So get more in detail now. If you are using asynchronous call,
Yep.
you are making another call asynchronous.
Yep.
So your function can be reused.
Yep. Your function can't be reused when your function is not finished running. So
This is an asynchronous call.
yes, but during this asynchronous call, so in this case, I'm saying I want to await. I'm doing a DynamoDB dot put something dot promise. So this is an asynchronous thing, right?
Yes.
But until the whole function, the whole thing has finished one way or the other, the container is still running. So from Lambda, as far as Lambda is concerned, this container is still running, but it hasn't given back a response yet. I don't know, I can't tell what's happening inside the runtime itself, so I can't reuse it.
So there is no point in using an asynchronous call. In other words.
There's no point using anything asynchronously, yes. So in fact, one of the things that Lambda makes me trickier with Node is that everything is async. You're going to end up doing all this work, but you're not going to reap any of the benefits. So with Python, where you can choose between async or synchronous, it actually makes life a lot easier. And same with Go as well, that I actually don't need asynchrony unless, for example, if I'm talking about my functions handling events from Kinesis or SQS, in which case I'm getting a batch of records. So in the case of Kinesis, I'm going to get a batch of records, and then I'm going to say, for every single one of them, please do something, and that do something is going to return a bunch of a promise. So I'm going to have a bunch of promises that I'm going to kick off async so that they run concurrently inside the same code, and then I'm going to say promise.or and wait for all of them to finish. In which case, then yes, it makes sense for me to run things asynchronously because now I'm using But for a lot of cases, no. Asynchrony is just more.
For a single call, it doesn't make sense.
Yeah. So for things like Python, actually you have that easy choice between async and the sync. It's actually quite nice.
It's like a long list.
So we've got like 10 minutes left. I'm happy for you guys to ask any more questions you have as well.
There's a file with a dot in front of it that means it hides it when you look at it normally. So there's all this random stuff you don't really see.
Yes, it is like this. I was just trying to show you
Encountered an error.
Okay.
Thanks. So I got to. But when I run it, it comes up with this error, which is adding this here. So I went in unless I put that in the wrong place. Under functions.
What's the error? So this feels like something tab or space, something like that.
Okay, so shall I try that? I've got VS Code rather than
Yeah, maybe it's doing something funky with coding. It's line termination or something like that. Yep.
hold.
Yeah, okay, so skills. You can do npm run. Yes, and then you have the user dash. That's basically just npm's way of saying please run this script and take whatever's on the right of this dash dash as arguments to this SQL. So you can say deploy, in this case, that you can deploy.
Yes,
Local.
Yeah.
And then space dash function and then space. And then every function which I think is hello.
Yeah, hello.
I think just hello. Try that.
Middleman.
Yeah, just leave it out, like, you don't really need to
Have you saved this one?
Control.
Yeah,
But no, then it will be AWS and then AWS will come back and things like. So it's just a middleman, you can't just go directly on AWS from this code. I don't know, gateway security
Did that one.
control.
It's also like it's primary security. Like,
Because they wouldn't let us directly in.
I mean, JavaScript I can help you with the simple JavaScript.
I
You just put anything and use it to, say for example, find D1. Simple JavaScript. No, yeah. Part security.
you get yours on rock.
Oh no, so you create a folder. Where's the folder? Patch the
I haven't set a
where's this running? This running is
It says select debug to an environment where and then run again.
this looks
hello world.
where is it downloaded?
on the program file.
Well, why are you in the so we need to be in that folder.
So
You need the users and
what is this?
You need an error.
so it needs to be this guy.
I ran it first, so I didn't.
So this guy, you know, like that. So they go, yeah. No. Okay, just start.
Oh, no, no, we didn't intend it. We used it.
Okay, cool.
Yeah, number 3.
I guess.
Missing where is the server?
And you're running from the browser.
Yes, that should be a bit easier.
If you run from the browser, you can see what that is.
It's going up now.
When it says service property is missing the service, what does that mean? You're right, it was. But now it's a new error.
Okay, so if you go to the top of this file, expecting that should be service.
Oh, so it should rename that to service.
So it was a service. I think it was supposed to place that. So that's the name of service. So
Yeah.
that should be hello world. That should be service.
So that should be hello world.
Yes.
Okay.
Now, do you have the VS Code?
I haven't got any.
Okay, so you have a.
No idea.
Okay.
I was thinking it nano, because I was like, busy. Which one do you want to take then?
On the search level, yes. So the thing is that that should be the actual service.
Well, right now, I'm just following the instructions.
No wonder it was unhappy.
I can't find it. That's the thing. I can't find where it's been deployed to.
So this is to create a function.
Yeah, it's a serverless function.
Hey!
So when the deploy to has the question, I deploy this to. USE.
I did, but then when I got the identification errors, I switched to VS Code.
Okay. So you don't need to contact that because that's a bigger step.
Just do it in VS Code. Yeah, but it's
You already
like
have.
So you use this
That basically
just
Other
Close
people
you
want to
close
code. So this is code to go to.
It's probably why I'm So go into that, open it up. Oh no, that's
This is the descriptor of the serverless function, and that's the actual budget function.
Oh, don't worry about cloning it. So go into the YAML file.
Deploy it. But what I want to see is
Open it up. Don't click the one. Open it up with VS Code. And then there.
So this is where I accidentally deployed it to lots of generals. Didn't really intend to do that. So where can I find this log stuff? It's not what I thought.
Monitoring.
Okay.
Yeah. Monitoring So those are the basic metrics.
Yes.
You can also click on one of those stuff and say take into account which metric itself, so you can get more sort of breakdown.
Yeah, so
So the is going to go to the top.
yeah. But once you get into it, you have to figure out. Okay, so
So I changed the things.
Okay.
I know.
But does it deal with massive codes anyway, because the nature of
I've done it.
using small codes or it's just examples?
well, I think that yes, it's a serverless function.
Oh god.
So the biggest thing that I've seen in there is like a few look.
Same as
Let's just find out. It's right there. Lots of languages. Start
Oh, God, yeah.
So it's actually, it has specific as usual.
Just give it to us digitally.
Yeah, okay, that's fine.
If you show us and carry on.
We just copy and paste it and basically get rid of them.
Ladies and gentlemen, ask your attention a minute. Even though the clock's fallen off the wall, I'm aware that it's moved to 8 o'clock. And we did say that we would finish at about this time. BCS staff need to go home at some point, so if you want some more sandwiches and food and drink, please help yourself outside this door now. I would like to thank our presenter very much, and afterwards we'll probably hang around for a little while and you can ask some further questions, and also come across the top. I'd like to present Jan as a token of our appreciation with a book that he's chosen called Agile Business Analysis.
I'm branching out.
So, thank you.
Cool. Thank you guys very much. And again, all the exercises are available on the GitHub repo, and you also find a bunch of slides as well, PDFs to some of the things I didn't get around to talk about today in terms of how to do write tests, how to organize your functions, and so on. So feel free to have a look at those as well.
Okay.
Yeah. There you go.
Thank you.
Thank you.
Thank you.
Ben.